Welcome. Today we will explore AutoML, which stands for Automated Machine Learning. It's all about automating the process of training machine learning models. Let's dive in. AutoML is an automated process for machine learning model selection, training, and optimization. It reduces the manual effort typically required in a machine learning pipeline. This makes machine learning accessible to individuals who may not be experts in the field. AutoML optimizes model performance automatically. Essentially, it streamlines the entire machine learning workflow, from data preparation to model deployment. Let's walk through a typical AutoML workflow. Step 1 is data preparation. Upload your dataset and AutoML will automatically handle pre-processing, cleaning, and feature engineering. Step 2 involves model selection. The system automatically selects and tests multiple machine learning algorithms suitable for your problem. Next, in Step 3 comes hyperparameter tuning. Optimal model parameters are discovered through automated experimentation. Finally, in Step 4, model evaluation occurs. The best performing model is selected based on automated testing and validation. Here's how you can get started with AutoML using Auto-Sklearn, a popular Python library. First, import the Auto-Sklearn classifier from the Auto-Sklearn.classification module. Then initialize AutoML by creating an instance of the Auto-Sklearn classifier, specifying parameters like time left for this task, per runtime limit, and ensemble size. Next, fit the model using your training data x_train and y_train. Finally, make predictions using your test data x_test. Auto-Sklearn automatically handles model selection, pre-processing, and hyperparameter optimization. Its simple application programming interface or API, similar to scikit-learn, makes it easy to integrate into existing workflows. Configurable time limits ensure practical runtime constraints. Ensemble learning improves model robustness, and it supports both classification and regression tasks. Let's explore some popular AutoML platforms. First, we have Google Cloud AutoML, a cloud-based solution that supports vision, natural language processing or NLP, and tabular data. It also has pre-trained models available, enterprise-grade security, and scalable infrastructure. Next, we have H2O AutoML, an open-source platform that supports multiple programming languages. It features automatic feature engineering, model interpretability tools, and cross-validation support. Finally, there's Auto-Sklearn, a Python-based framework compatible with scikit-learn. It also has meta-learning capabilities, ensemble methods, and Bayesian optimization. Here are some best practices for using AutoML effectively. First, clean and pre-process your data thoroughly before feeding it to AutoML. Second, set appropriate time constraints based on your dataset size and complexity. Third, monitor computational resources during the automation process. Fourth, validate models on holdout sets to ensure generalization. Fifth, review model explanations and feature importance for insights. How do we measure the success of AutoML? Let's consider a few key metrics. First, evaluate model performance by comparing accuracy and precision metrics to traditional machine learning. Look at cross-validation scores and stability, as well as receiver operating characteristic or ROC curves and area under the curve or AUC metrics. Next, assess time efficiency by measuring the reduction in model development time. Consider the automation of repetitive tasks and faster iteration and deployment cycles. Third, examine resource utilization, focusing on computational resource efficiency, memory usage optimization, and cost-effectiveness analysis. Finally, measure business impact by evaluating the return on investment or ROI on machine learning projects, time to market improvement, and team productivity gains. Let's look at the future of AutoML. Expect to see more advanced neural architecture search, which involves the automated discovery of optimal neural network architectures using reinforcement learning and evolutionary algorithms. This will enable more efficient and powerful deep learning models. Also, expect continuous learning systems. These AutoML systems can automatically adapt and retrain models as new data becomes available, ensuring models stay current and effective over time. Furthermore, automated feature engineering, more sophisticated feature discovery and creation techniques using deep learning and domain-specific knowledge to automatically generate optimal feature sets. Finally, expect edge computing integration. AutoML systems optimize for edge devices, enabling automated model development and deployment for Internet of Things or IoT and mobile applications with resource constraints. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.